Hi, today we're breaking down the difference between vector search and GraphRAG and when you'd actually use one over the other in a real-world GenAI application. If you've ever had an LLM confidently spit out the wrong answer and wonder how to fix it, this might help. Quick recap. In most RAG setups, you take your docs, split them into chunks, and create embeddings, which are high-dimensional vectors, or numeric representations of the data. The more numbers in the array, the more dimensions. When a user asks a question, that query gets a vector representation too, and a vector search finds the most similar vectors to that question. It's fast, it's scalable, it works pretty well for unstructured data like support documentation, product descriptions, or knowledge bases. The pros of vector search are that it searches based on semantic meaning versus only keyword or lexical searches. It handles imprecision pretty well, things like unusual terms and typos, and you get improved relevance in the results over just a plain LLM. But it does have a blind spot. Vector similarity doesn't capture how things are related, just that they seem similar. Let's say you're asking about the materials used to make a particular brand's clothing item. Vector search might retrieve documents that mention clothing materials, products, or supplier sourcing, but not necessarily gather all of the right context or connections. The company may use those materials and sell that product, but it may not use those specific materials for that particular product. This can lead to hallucinations where the LLM tries to fill in the blanks, or just a wrong focus. You get tangentially related information, but not an accurate or complete answer. GraphRAG tries to solve this by adding a step to query a knowledge graph, which is a structured network of facts, where entities equal nodes and relationships equal edges. You can query paths, connections, constraints, things that a vector search just doesn't track. The knowledge graph can retrieve and utilize the connections in your data to gather more comprehensive and accurate context. Where other solutions might require making potentially inaccurate assumptions to bridge missing pieces, Graph can fill in those gaps with concrete data. This can mean the difference between somewhat uncertain in the answer and 99% certain, and technology and business much prefer certainty. As an example, instead of retrieving a blob of text saying Sarah was promoted, a knowledge graph stores that Sarah was promoted to a VP of engineering role, and that role reports to the CTO. That lets the model answer who reports to the CTO without guessing. The advantages of GraphRAG are that it reduces hallucinations using multi-hop reasoning. You get better reasoning through connected data and improved explainability. It's easier to trace and debug the information coming back. So, should you ditch vector-only RAG? Probably not. Here are some starting points. For use cases like frequently asked questions, customer support, and chatbots, vector search is a great place to start. For compliance, audit logs, chain of events, GraphRAG might be a better solution. And anything that involves reasoning or verifiable relationships, that's also a great use case for GraphRAG. In cases where semantic search and near relevance is sufficient, there's no need to move past vector search. However, in cases where inaccuracy is unacceptable or bears high risk, the additional context with GraphRAG can be well worth the investment. And many systems actually combine multiple search approaches together using hybrid retrieval to get both speed and structure. There you have it, vector search versus GraphRAG. Vector search is simple and fast, but blind to connected structures and data. GraphRAG comes in when you need more structured, traceable, and accurate responses, especially when hallucinations are unacceptable. The future? Probably a mix of both. If you'd like to know more about vector search and GraphRAG, check out Neo4j Graph Academy's free courses and start building more trustworthy GenAI today.